Aristotle's perspective on mathematics. Aristotle was educated in Plato's academy, in which it was commonly argued that mathematical objects like lines and numbers exist independently of physical beings and are thus separable from matter. Aristotle's conception of the hierarchy of beings led him to reject Platonism, since the category of quantity is posterior to that of substance, but he also rejects nominalism, the view that mathematical things are not real. Against both positions, Aristotle argues that mathematical things are real but do not exist separately from sensible bodies. Met. 1090 at 2930, 1093, B2728. Mathematical objects thus depend on the things in which they inhere and have no separate or independent being. Met. 1059, B1214. Although mathematical beings are not separate from the material cosmos, when the mathematician defines what it is to be a sphere or circle, he does not include a material like gold or bronze in the definition, because it is not the gold ball or bronze ring that the mathematician wants to define. The mathematician is justified in proceeding in this way, because although there are no separate entities beyond the concrete thing, it is just the mathematical aspects of real things that are relevant to mathematics. DC 278 at 26. This process, by which the material features of a substance are systematically ignored by the mathematician, who focuses only on the quantitative features, Aristotle describes as abstraction. Because it always involves final ends, no abstraction is possible in natural science. PA 641 B1113, Phys. 193 B3135. A consequence of this abstraction is that why questions in mathematics are invariably answered not by providing a final cause, but by giving the correct definition. Phys. 198 A1421 230-34. One reason that Aristotle believes that mathematics must proceed by abstraction is that he wants to prevent a multiplication of entities. For example, he does not want to say that in addition to there being a sphere of bronze, there is another separate mathematical sphere, and that in addition to that sphere, there is a separate mathematical plane cutting it, and that in addition to that plane, there is an additional line limiting the plane. See Katz 2014. It is enough for a mathematical ontology simply to acknowledge that natural objects have real mathematical properties not separate in being, which can nevertheless be studied independently from natural investigation. Aristotle also favors this view due to his belief that mathematics is a demonstrative science. Aristotle was aware that geometry uses diagrammatic representations of abstracted properties, which allow one to grasp how a demonstration is true not just of a particular object, but of any class of objects that share its quantitative features. Humphreys 2017. Through the concept of abstraction, Aristotle could explain why a particular diagram may be used to prove a universal geometrical result. Why study mathematics? Although Aristotle rejected the Platonic doctrine that mathematical beings are separate, intermediate entities between perceptible things and forms, he agreed with the Platonists that mathematics is about things that are beautiful and good, since it offers insight into the nature of arrangement, symmetry, and definiteness. Met. 1078 31b6. Thus, the study of mathematics reveals that beauty is not so much in the eye of the beholder as it is in the nature of things. Hoinsky and Polanski 2016 5160. Moreover, Aristotle holds that mathematical beings are all potential objects of the intellect, which exist only potentially when they are not understood. The activity of understanding is the actuation of their being, but also actuates the intellect. Met. 1051 at 2633. Mathematics, then, not only gives insight into beauty, but is also a source of intellectual pleasure, since gaining mathematical knowledge exercises the human being's best power.